Say whenever you're ready, Jeff.
Okay, we'll begin. I'm sorry for this mess up here. I don't know what happened, but I think we all had the same problem. We couldn't get on from what was listed there. I had to go around sideways someplace. Um, just a little review of the things that we've done. We when it came to creation and science, we had pointed out that there is one approach that's taken that says that the 6 days are not days as we know them. One of the authors that uses that technique points to a volume written by Rabbi Monk. I've never seen it, but he uses that approach. He says that days are not days, and puts days in apostrophe marks or quotation marks as he goes along, just to emphasize that it's not. And they treat days as if each day represents a geological epoch, that is then a long period of time stretching into millions of years. And we'll show a chart of the coincidence between the days and these many, many millions of years. But at any rate, that's the approach that's taken, and they justify the connection by showing that the things that are mentioned in the Torah about what was created in each day or what was made in each day, there was only one creation, but there was other things that take place, 3 creations actually, and shows the key words of each day and how it ties in with geological and archaeological findings that we have in the world, astronomical, and in that way they relate millions of years, close to 16 billion or 15 billion years, with the 6 days of creation, and we'll show a chart later on. We didn't take that approach here because we followed the Shita of Rashi and the Ramban, both of whom, among others, say that when it says days in the Torah, it meant 24-hour days like we are accustomed to here on earth, and not epochs and not millions or what have you. And in order to justify that approach and go with that approach and see how science connects with that and explains that, we got involved with first an explanation of how we got started with the Big Bang, which now every scientist that's worth their weight in hay or what have you will say that there was a beginning. There was a time when they didn't believe there was a beginning. Aristotle had convinced people that you can't have anything come from nothing, and therefore it had to be that whatever we have was been here all along. So there was no beginning. Don't ask me kashas or what happened in the beginning or where the stuff came from, but that was it. And that's not justified. Now everybody agrees that there was a beginning. We have an expanding universe, and we can trace how far back it goes, essentially, and they come up with the years of 16 billion. And our task was to see how 16 billion fits into 6 days. And we discussed a little bit about that, pointing out that it required the theory of relativity, theory of general relativity, special relativity. And this became clear as just recently, 1965, with the measurement and the discovery of this background radiation that exists out there in our world, which is a carryover of the radiation that was there at the Big Bang, and the value of the frequency of the radiation that was measured in 1965 by Penzias and his colleague, exactly what would be expected from a Big Bang that took place some 16 billion years ago, this leftover radiation, which is still traveling around and you can pick up from any direction in our universe. So we went along with that, and we'll show you a chart, to show the juxtaposition. And anyway, the bottom line there is that what might have gone as 6 Earth days, right? In the theory of relativity, if you measured it from some kind of a moving system, it could be something that was really a lot longer. We're gonna read something for you now, which tries to give you a little bit insight into what that means. This is something which Dr. Schroeder in his book on Science and God brings down. Yeah, okay. I hopefully I don't need that. All right.
Pick up the sheet on the floor, Jack. Are you looking for the sheet on the floor, Jack?
No, I'm looking for the page that I put in here. I lost it. Okay. Dr. Schroeder asks us to imagine the following situation. What he calls like a Pony Express type of the mail system. Essentially, what we want to do is take the background radiation that was discovered in 1965, cosmic background radiation, and use that as a universal clock. And this is the example that tries to bring home a little bit of what we said. Suppose, he says, suppose we have the following. Let's imagine again the Pony Express period when that's how they had to deliver mail by human beings riding horses, what have you. Suppose you receive a letter from a friend, and in it he promises to send you another letter in 6 days. Unbeknownst to you, during those ensuing 6 days, he has been traveling away from you. As promised, on the day 6 days, you receive, on the day 6, he sends off the letter as he's supposed to. But now, because of his travels, delivery takes an additional 6 days. And so you don't get the letter until 12 days, right? Now, if you get the letter, he told you he's going to mail one 6 days, so you assumed it. It's not 6 days, it was 12 days. If the interval between the letters marked the passage of time, the receiver of the letters would assume that 12 of his days equals 6 of the sender's days, because the sender said he's going to send every 6 days, but you got it in 12 days, so there must be a difference in time between the two. The perception that 12 of his days equals 6 of the sender's days, the perception would be that the sender's time was passing half as fast as the receiver's time. In the letter, the sender wrote that he would now send a letter each day. Every day he's going to start sending a letter. Again, unbeknownst to the receiver, S now travels back toward the receiver with the Pony Express mail. Each day, as promised, S sends off a letter. Because the sender is now traveling back towards the receiver R, each letter takes a day less than the previous letter to arrive, which means that the 6 letters all arrive one right after the other, only minutes apart. The receiver can only assume that the time that the sender has during the past 6 days was going much faster than the receiver. The perception of the receiver is that a full day has passed for the sender in a few minutes, the time between the arrival of each letter. If the letters were and are the only contact that R and S ever have, it will never be possible to know whether the changed rate of the time was truly happening or was only perception. We know only because we see both the receiver and the sender. But that's something which the receiver and the sender can do. So something that moves very fast has time slowed down. And that's what is used to try and explain the 16 billion years versus 6 days. When the universe was created, the rate at which it was moving was fantastic. I pointed out last week that it's within the first 3 minutes, there was a tremendous change of cooling down and things started to develop. That was Weinberg's book called The First 3 Minutes After the Big Bang. At any rate, that's the approach that's taken. And if you go through that approach, you come up with, I don't know if you'll be able to see this. Can you? I don't know if you can see the chart here. Let me just read it to you. According to this approach, then, from creation to the end of day one would have amounted to about.
Got it.
Sorry?
Bye-bye.
Oh. From creation up to the end of the first day would it be 4.5 billion years. From the end of the first day to the end of the second day would be another 150 billion years, a million years. And then from there to the next day, it's 50, et cetera, all the way up to Abraham. By the time you get to Abraham, you are at 3.8 thousand years, right? 3.8 thousand, which is roughly 4,000 years before us that Avraham Avinu was born and lived. Avraham was born in the year 1948, right? That's the year. It's not too hard to remember. Anyway, that's the approach that are taken by the scientists that want to treat each day as a true 24-hour day, and then the difference in time sequences is related to the general theory of relativity, actually, and they don't have any problem with it. But there are a few things that were not going to be discussed here, which one has to consider, and that is, in the 20th century, one of the main branches of science that matured and developed was quantum mechanics, based upon essentially something that Einstein had done with the photoelectric effect, showing that light can behave like a particle. Light, which we thought a photon is something that's just a wave, which has no real mamushus, it's not really has any mass of any kind, but it behaves like it does have mass. And that's the famous two-slit experiment, which I don't want to get into, but if you were to shine light on a strip of black paper that has two parallel, clear vertical lines through it, and you shine the light right in the middle between those two, what would you expect to see on the other side if you put up a screen? So most people say you would expect that the light would go through, some light would go through one of the openings and give you a spot on the wall in that direction, the other one over there and a spot on the wall in that direction. That's what you would expect. Light travels in a straight line. But that's not what happens. When the light gets to these openings, it spreads out on the other side. You get what's called an interference pattern, and you will see a series of light and dark, light and dark, light and dark, light and dark. Particles can't behave that way. Light can behave that way. Nevertheless, if you think of light as a particle, as Einstein said in the photoelectric effect that light has particle-like behavior, etc., there are experiments that show that particles do behave that way, and they can be where you don't expect them to be. In a nutshell, quantum theory said that you cannot, one of the things it said, that you cannot measure the position and the speed of a particle at the same time. That is, if you know you have a particle sitting over here, and you want to measure its position by shining, how do you measure it? You got to shine something on it. You got to shine light or something on it. Whatever you interact with that particle is immediately going to cause that particle to move. So it no longer has the same velocity it had the moment before you started to look at it. So that velocity is not going to be measured correctly with the position. You can either measure the position or you can measure the velocity. You can never measure both at the same time. This leads to what's called the uncertainty principle. It turns out, for better or for worse, and as difficult as it may be to understand, is that it's possible for something to come from nothing. That is to say, it is possible that one of the possible states that a particle can be in is the state in which it's not there at all. So it sounds crazy, and in some respects, maybe it is. In other words, as soon as you begin to measure something, you change what it was. Measurement causes a change in the thing in which you are measuring. And therefore, for all you know, right, there was nothing there before, and now there's something that is there. What I'm saying is that there is a theory that says that it's possible that before the earth and God created this world, where we imagine that there was nothing there, right? But in that nothing, they could have had something. In other words, you could argue that modern physics, modern science, and quantum mechanics has been proven to be more than just a theory. It's operative all over in many, many ways that prove itself to be true, just like the theory of relativity and others. They're not really theories anymore, they're laws, so to speak. Right? It is possible that something could be created from nothing by one of these, what we call quantum irregularities. Right? One of these things which are very, very unusual. I refer you to the famous articles on Schrodinger's cat, right? The cat that can be in two different places, at one time, what have you. But it's strange to understand. But it's something which is possible. And if somebody turned out to say that there was something like that happening, it wouldn't bother us, because Kodesh Baruch Hu was there before the world began. That's what he wanted to do. So I just want to point out that there are meetings that take place regularly, right? The Torah, and the light of the Torah. These, I think, are annual or semi-annual. I got a present here of these to show you from Marty Levine. He had these. This is from 2001, and this one 2002. This is the journal from the annual meeting, right? And just read the topics that are discussed. Adam and Eve collapsed the quantum wave function. The role of the human observer in nature. That's what we're talking about. Soul and body, stem cell research, human cloning, genetic engineering, all things that are modern kind of stuff. And this is already 20 years old, those things, more things. All of which are handled and discussed. And never have we found that there's a contradiction between what science is uncovering and what we believe is in the Torah. I just want to call a couple of things again, talking about the science. Some interesting insights. Jewish calendar, our whole life is based upon the lunar calendar. A little bit the sun also, but basically we live on the lunar calendar. It's very important to know exactly what the average length of time is from one new moon to the next new moon in order to set up this calendar. To calculate the Hebrew calendar, precise knowledge of the average length of the lunar month is essential. Variations from month to month make it extremely difficult to obtain an exact figure. Concerning the value, the value of the 1 month, the Gemara in Rosh Hashanah on Daf 25a, right? Chaf Hei Amud Aleph, reports, Rabbi Gamliel told them, I have a tradition from my grandfather's house that the renewal of the moon is not less than 29 1/2 days plus 2/3 of an hour and 73 chalakim. 1 chalik is 1 divided by 1,080th of an hour. Here's what he said. It gives you an exact number. Comparison of this figure to the one accepted by astronomers today shows that the difference between the two is only 1/2 a second. 1/2 a second is the difference between what the Tanoim had, as a reference, right, from Rabbi Gamliel and what they've been able to do. Now, Rabbi Gamliel did this figuring, whatever came out, his grandfather's figuring, right? Didn't have a telescope to work with, it didn't have nothing, right? How he got it, we don't know. But that's what is 1/2 a second was the difference between that and what modern people say today. They had no better than that. And again, the Chachamim obtained this figure precise to an amazing 1 part in 5 million in an era well before the invention of clocks. And he points out, the author, that it's not only Jewish sources such as Rabbi Yehuda Halevi, the Kuzari, the Rambam, and Hilchos Kiddush HaChodesh, etc., which record that the Jews possess scientific knowledge in advance of the Greeks. Non-Jewish writers commented on this as well. It said somewhere that it was from the Jewish people that Pythagoras derived the philosophy which he introduced among the Greeks. I'd like to give you an example of the hidden information that's related to science that we have in the Torah. And some of you are probably well familiar with this also. There are 2 key numbers in the sciences that pop up all the time. Neither one of the numbers is a nice number. I used to tell my students I call numbers nice, right, if they are rational. Rational means if they are the ratio of 2 whole numbers. So a whole number is rational because it's a number divided by 1. So the number 7 is a rational number because it's 7 divided by 1 is 7. 3/4 is a rational number. It's 3 divided by 4. Right? Those are rational numbers. A rational number either has no decimal part, like the number 6 is 6/1. It's 6. There's no decimal, right? Or it has a decimal part that ends. Right? For example, 3/4, right, has a decimal part, .75, right? 3/4 is 0.75. Or if you have the other way around, 4/3, and you divide 3 into 4, you get 1 dot, and what follows? 3, 3, 3, 3, 3, 3, 3, 3, Leolam Va'ed. It has an infinite decimal part that repeats itself. It could repeat itself 1 number, like 3, 3, 3, 3, 3. It could repeat itself 2 numbers, 2, 1, 2, 1, 2, 1. But if it's a repeating decimal, right, or if it's no decimal, those can be turned into rational numbers. Unfortunately, the 2 most important numbers that are treated in science are not rational numbers. And you know these numbers. One of them is the number that we call pi. pi is not a rational number. It's 3 point, and then is a long, long, forever going list of numbers which don't repeat. That's called an irrational number. There are other irrational numbers. The square root of 2, there are other irrational numbers. But pi is the famous irrational number, very prominent in science and physics, mathematics. You can't talk about the area of a circle or what that without using number pi. And one of the questions on my list, is to find out why Kadosh Baruch Hu couldn't have made it much easier for us. Why do you have to have a number like pi? Right? I still don't know why the acceleration of gravity came out to be 9.8 meters per second squared. Couldn't be 10. Now that we could have made 10. You could have just changed the size of the meter and you could have turned it to 10 jacks, right? 10 jacks is meters per second squared, right? It would be a new number. It would have been perfect. Why mitch the students with 9.8? Right? Okay. Anyway, that's too late. The other number is a number which you know familiar too. If you have a bank account, you should be familiar with this number, right? If you get interest, right? It's called the compound interest formula, and it involves the following concept. Suppose you have a very nice bank, and it gives you 100% interest every year. At the end of the year, you get 100% interest. So you deposit $1 in the bank on the beginning of the year, and at the end of the year, how much money are you going to get back? $2. Because you're getting 100%, which means whatever you have, it gets doubled, right? Wonderful. Then the bank says, you know what? I'm going to be nicer to you. Instead of giving you the 100% at the end of the year, I'm going to give you 50% after 6 months, and then take that 50% plus the dollar that you put in, and I'm going to give you another 50% interest on that at the end of the next 6 months. That's called compound interest. So if you do that, you will come out with more than $2. I mean, maybe the example I just gave, you come out with $2.25, $2.20, whatever. You come out with more than $2. Then the bank says, you know what? We're so happy with you as a client. We're going to give you 100%, but we're going to divide it up into 12 parts. And each month you're going to get 1/12%. And then you keep adding that together. And at the end of the year, you'll get even more money than you would get the other way. And that's true. The bank is so crazy that they decide we're going to do this every single second of the year. Now a year has roughly 3 times 10 to the 6 seconds or something like that, millions of seconds, right? So they're going to do this every second. They're going to take the 100% and divide it up into that many parts, but they're going to do it every single second compound. Well, they can do it not only every second, every 10th of a second, every 100th of a second. There is a limit to how much money you're going to make. You will not make more than $2.72. That's a magic number. And in the science, it's the number E. It's the base of the natural logarithms, E. Right? And that's it. That's it. You'll never get more than that. No matter how many times they compound and they want to be nice to you, that's all you're going to get. 2.7. Strangely enough, there are references to these numbers in our Torah. So I want to just bring to you the calculation of where we get pi from. This was something which was uncovered by the Vilna Gaon, I believe, many, many years ago. I don't know if you know this, but the Vilna Gaon was a very smart man. He wrote a book on geometry that was required reading in some of the major universities in Europe if you were going for a doctor's degree in any scientific area, especially if it was in physics or mathematics. There was a copy of the book in the YU library. I remember seeing it. I think I was still an undergraduate when I got a chance to see it. infinity is marked off as an aleph zero. I mean, it was written obviously in Hebrew, but it was translated. Vilna Gaon was a brilliant man. I remember the day that Ripley's Believe It or Not, used to have a thing that always got published in one of the newspapers. I don't remember whether it was the Post or the Daily News, but there was always a Ripley's Believe It or Not. And I remember the day where the Believe It or Not was the Vilna Gaon knew, and he lists all of the things that he knew by heart, right? The Vilna Gaon knew all of Shas, probably, but everything. And a lot of great people know that too. It's not just the Vilna Gaon, all of them. Famous story about Rav Moshe Feinstein's himself. He was sitting and giving a shiur on Friday to his smicha group, and he mentioned quote, a citing a Shulchan Aruch in Siman Satazas Sof Cotton, and he mentioned where it was. And one of the Talmidim, I think this would be chutzpah. Who wanted to tell me and said, Rebbe, I think it's not Sifkat and Hay, it's Sifkat and Vav. I mean, the nerve to say something like that to your Rebbe, I don't know. Anyway, Moshe looked at him and said, no, it can't be. And the Talmud insists, no, I think that's what it is, Rebbe. So Rebbe said, go get me the Shulchan Aruch. So everybody's wondering what's the big difference? So he brought them the Shulchan Aruch, and the Rebbe opened it up, and he showed the student that the Rebbe was right. Sifkat, it was Sifkat and Hey, not Sifkat and Vav. And then the Rebbe explained, you don't understand. I don't have time to go and check every one of my citations to make sure they're right. I have to know it all when I write down, otherwise I'll never finish writing the number of tshuvas I have to write every day. I can't go checking them all the time, which I have to know them by heart, and I can't afford to make a mistake. So when you tell me I was wrong, I had to go check and make sure that I wasn't wrong, because if I was wrong, then I'm in a lot of trouble. Anyway, so I mean, the Vilna Gaon wrote this book, as I say, on geometry, and he evidently discovered this insight on where pi is written in the Torah. I first heard about it from my calculus teacher at YU first year, Dr. Listman, Alav Shalom, who was a brother-in-law of the Rav's, married to the Rav's wife's sister. So there is a pasuk in Malachim Aleph, Perek Zion, 7th Perek, the 23rd pasuk. I don't know if I hope you won't be able to see it when I hold it up, but I'll read it to you. Vayas es hayom mutzok, eser ba'ama misvaso ad svaso hogol soviv, v'chomesh ba'ama komoso, v'kav shaloshim ba'ama yosovo so soviv. Simply translated. This is now Shlomo building the Beis HaMikdash. Then he made a tank of cast metal. This was a mikveh, 10 cubits across brim to brim. That means the diameter was 10 cubits. Completely round. It was 5 cubits high, and it measured 30 cubits in circumference. So it's 10 meters diameter, 30 meters in circumference. Now it doesn't.
It's 3.
Huh?
Pi is 3.
So yeah, I'm just saying. So the Kodesh Baruch Hu made a mistake, or Shlomo made a mistake. How do you write that? That's a glaring error. That tells me that pi is 3. We know pi is not 3. I mean, that's shekel. Why? Strangely enough, the word for line diameter here, the kav, is spelt kuf vav hey, right? Kuf. Won't be able to see it. I can show it from today to tomorrow. I should not pick it up. Kuf, right? Vav hey. That's how it's written. But it's pronounced kav. The hey is silent. The same pasuk shows up in Divrei Hayom and Beis, where they're repeating again what Shlomo did. Exact same pasuk, one change. In this pasuk, the word nisvaso, atzvaso, says ad. That pasuk says al instead of ad. Otherwise, exactly the same, except in the pasuk in Malachim, kav is spelled with an extra hey, and in the pasuk in Divrei Hayomim, the hey is not there. So the word line, right, kav for the line diameter, is spelled with a hey in Malachim, without a hey in Divrei Hayomim, and even when it's written with the hey, it's not pronounced. It's still pronounced kav. You don't know. So the Vilna Gaon says this is a key and a clue to the number pi. He said, take the number kav, kuf vav hey. Put on your thinking caps, right? The gematria, kuf vav hey. Kuf is 100, vav is 6, hey is 5. So kuf vav hey is 111. Okay, right? Got it? Kuf is 100, well, 111. Kav doesn't have the hay, that's 106. 111. If you take 111 and divide it by 106, divide it, kav is a line. So if you use the word kav to divide the kav with the hay valued and the kav without the hay, you get a number 1.04716, going on and on and on. If you multiply that number by 3 as a correction factor to the 3, right, of what you think pi was, if you use that as the correction factor, then you get 3.1428. You get pi correct to the first 3 digits. So the Vilna Gaon says that was the key, the clue of where the number pi is in the Torah. Right? Whether that was before the Greeks got it or after the Greeks, I don't know, but it was there. Right? And the compound interest formula, which happens, I mentioned before, that gives you a number that is 2.718, 2.4 to 3 decimals. Right? That is, it's more than 2.717, but it never reaches 2.718. So 2.72 essentially, or 2.73 is the most money you would make on a compounding of that $1, an infinite number of times in the year. I was told, as I recall in class by Dr. Listman, that number 2 can be found in Torah. I never heard or saw where the source of that is, but somebody, he did say that he thought E is also to be found somewhere. I thought that's something of interest. Next exciting thing is the number of stars. Chazal had a fix on this one, number 2. Yeah, the number of stars. Now, until early in the 17th century, when Galileo applied the recently invented telescope to survey the night sky, knowledge of stars was limited to the few thousand visible to the unaided eye. Thus, too, was the prevalent opinion concerning the number of stars. It is interesting to note the following Talmudic passage. This is a Gemara in Brachos, Aflamed Beis, Omid Beis. The Talmud is telling a story, allegorizing the people of Israel, Bnei Yisrael, compared to the spouse, Lahavdil of Kadosh Baruch Hu, complaining to him that he has forgotten her. So Am Yisrael is complaining Kadosh Baruch Hu that he's forgotten us. The Holy One, blessed be he, said to her, the congregation of Israel, that is, my daughter, I created 12 constellations. I created 12 constellation heaven And for each constellation, I created 30 armies. And for each army, I created 30 legions. And for each legion, I created 30 brigades. And for each brigade, I created 30 regiments. And for each regiment, I created 30 platoons. And on each platoon, I hung 365,000 myriad stars, the Hest, corresponding to the days of the year. I created them all for you, and you say that I abandoned you? Now, what is this number? If you multiply all these things together that he just said, now the constellations and the right, constellation, armies, and brigades. Now, these are technical terms in military life. I'm not familiar with them or what sizes they are. But multiplying together the figures in the Gemara, we come to the astronomical number. I can't read the number, but I don't know what the names of these places are. But basically, no, I can see it. Basically, it's 1,064, 340, 000, 000, 000, 000, in short, approximately 10 to the 18th stars. That's called a trillion stars. In American usage now, it's quillion, I don't know, but a trillion stars. Even today, there is no exact figure for the number of stars. We only have rough estimates based on astrophysical models. But the Encyclopedia Britannica mentions trillion, 3,000 stars. It is amazing, trillion is sort of that number we just read off to you. It is amazing that our sages cited a figure close to the same order of magnitude as that which scientists have only recently been able to establish. And the Gemara, going back to the year 400, the Common Era, and then the scientists didn't get to that number until much later. The other thing, comets. The existence of comets, which approach the Earth and then disappear, has long been recognized. However, there are some comets, as you know, which reappear at fixed intervals. Right? Halley's comet every 87 years or something like that. It is accepted this phenomenon was only discovered at the end of the 17th century. Gotta go to the page 12.
Let me get it.
Okay, I don't need that. Just
Oh, all right, so put it there.
At the end of the 17th century, the English astronomer, Edmund Halley, it's Halley's comet named after him, analyzed the orbit of a comet. Right? However, 1,600 years earlier, Rabbi Yoshua already knew about these stars, as we find in the Gemara. This Gemara is in Horius on Daf Yud Aleph. Rabbi Gamliel and Rabbi Yoshua were traveling by ship. Rabbi Gamliel had bread, and Rabbi Yoshua had bread and fine flour. Rabbi Gamliel's bread was used up, and he relied on Rabbi Yoshua's flour. Rabbi Gamliel said to him, "Did you know that we would have such an extended delay that you brought along flour?" And Rabbi Yoshua said to him, "There is a star which rises once in 70 years and misleads the sailors. And I said, perhaps it will rise and mislead us and cause a delay." Right? Here's Rabbi Yoshua saying he knows already about a star that comes around once every 70 years, which is Turns out probably to be Halley's comet. Some maintain that this was a reference to Halley's comet, which recurs every 75 or 76 years. Others questioned this claim because at the time of the comet's appearance in that period in the year 66, Rabbi Gamliel was only in his 20s, too young to have students, as suggested by the continuation of the Gemara there. However, this is not relevant to our claim that Rabbi Yoshua knew about the periodicity of comets 1,600 years prior to its discovery by modern science. Just one more quickie. There is a mission in Shabbos. And Shabbos, the sixth parak, the sixth mission. On Shabbos, one may go out from a private domain to a public domain with a sella placed on a sore on the foot. Right? You have a sore on your foot. You can put a sella on it, and it can be bandaged. And Chazal let you walk out with it from Rishus Yoga to Rishus Rabbim on Shabbos. The Gemara on Daf Samach Hey Amid Aleph explains that this refers to a wound which is treated by tying on a silver coin. Silver is the optimal word here. Our sages discuss which property of the coin is significant in affecting the cure. If it is the application of pressure, one could use a shard of pottery instead of a coin. If it is the silver which cures the wound, one can use a piece of silver sheet. The answer was that the embossed relief on the coin is significant in the healing process. They argued that based on this, one can use an embossed piece of wood. The conclusion of the Gemara is that all three properties are important in effecting a cure. The question of why the Gemara specifies a coin which is made of silver and embossed bears further study. And the author says his father was a doctor and told him that all this comes under the heading of God's secrets are revealed to those who fear him. It's a pasuk in Tehillim. We know today that silver has antiseptic properties and is in fact used as a component in antiseptics. What is more, its effectiveness is proportional to the size of the surface area. The greater the surface area, the greater the antiseptic effect. It follows that an embossed coin with its greater surface area will provide a cure more effective than a flat piece of silver. The point is, Chazal knew a lot of stuff. They knew a lot of science. They didn't go to university to study the science, I'm sure, but somehow they got it. I always tell the story of Hanukkah time when we passed. I think it was in 1921, 1922, thereabouts, that the Brisker Rav gave as explanation for the burning of that candle that the Gashmonoyim lit for 8 days. He gave as an example Einstein's theory of relativity. But the formula E equals mc squared means that you can convert an amount of mass m into energy under the right conditions. So the Brisker Rav said, Kadosh Baruch Hu allowed the oil in the flask, right, that was burnt. He allowed the oil to use up all of its mass, or whatever it needed to do for 8 days. Use up its mass and convert it into energy. That was the great miracle of Hanukkah. Kadosh Baruch Hu allowed nature to do something which ordinarily it wouldn't do. Ordinarily, you don't get a piece of mass to convert itself into energy without using an awful lot of energy to do it. In other words, in order to have a nuclear bomb, an H bomb, you really have to have an atomic bomb. You need an atomic bomb first to create enough heat in order to get the other material to actually change into energy, because it's not that easy. And we have, plants that do it. They set up all kinds of things to get the nuclear energy. But here, the Brisker Rav said, Kadosh Baruch Hu allowed the oil to manifest itself, right, to use up its mass, into energy, right, which it normally would not have been done, and that's the miracle of the Ness of Hanukkah. All right, Rabbi Osai, we've concluded today's class, and this is the last class for a while. I've been asked by the incoming administration of the shul to undertake some other task, which is going to keep me occupied and busy. So we have to postpone maybe sometime after Yontif, after Pesach, we'll be able to find a few more weeks to put in. And if there's interest, we'll do a few more of these. But for the time being, this is going to have to be the last one. Have a Freilich and Purim, and stay safe. That's the important thing. Thank you so much for joining us and being here. Oh, I'm going to show you this. This is how close I am to Einstein. See? Oh, people left. All right, you're still here. This is a piece of wood that came off a tree that Einstein planted on the campus of New York University in the Bronx on April the 23rd. Oh, I'm sorry, May the 23rd in 1921 when he visited the campus. And this tree grew, and in 1992, I think it was, they had to cut it down, and somebody in the history department, no less, decided to cut it up and give people pieces of the Einstein tree. It says planted May 23rd, 1921 on the NYU Bronx Community College Hall of Fame campus in New York City. Albert Einstein, E equals MC squared. Einstein lived from 1879 to 1955. Think great thoughts. And I got one of the first pieces as chairman of the physics department. They gave me one of the first pieces that's cut. And I keep it around as a memento. Okay, have a great one. And please stay safe, whatever you do. All right, be well.